Good day, everybody. Miss Berg here, and Zero to Matter. So the first thing you want to do is make sure you have these notes out and go to the bottom of the very first page. So these are your Introduction to Matter notes. They should be in your Google Drive. Hopefully you already pulled them out due to the warm-up, and we're going to be filling them out as we go. If you need to pause at this time, go ahead, but make sure you have that note page out. So the box at the bottom of your notes where it says, what is happening here? It's referring to this wonderful GIF that is currently on my screen. So take a look at what's happening here. If you need to pause the video at this time, go ahead. So here it says raise your hand or type in the chat. That's okay. You don't need to do that, but pause here to type in that box what you think is happening. And in addition to saying what is happening, go ahead and say, why is this happening? Pause now to fill out that section. All right, hopefully you've paused and hopefully you filled it out. Basically, what we have going on here is a chemical reaction. We have two fluids that are being put together and they are creating a brand new substance. This unit will be focused on looking at the atomic scale to try to explain why things at the human scale behave the way they do. So when we have these two fluids together, why is it making this solid structure? Why is it making this brand new substance? That's part of what we are investigating in this unit. So vocabulary alert, go to the last page of your note sheet. It should look like that table at the bottom of the screen. Fill out the vocabulary table as we go through this slideshow. Red terms are the vocabulary. Write down the definition from the slide. Write down your own definition, meaning in your own words. So it just means you rephrase it so when you go back and read through it, you know what that definition actually means. And then write down an example from class or your own. There'll be examples on every slide. Go ahead and pause the video anytime you need to in order to fill this out. Again, if you miss anything today, use the slides in today's folder to catch up or just pause the video. The first thing we're going to cover is what's the matter? Yeah, what is matter? Well, matter is the stuff that exists in the universe. Matter equals anything that has mass or volume. So you can see the red matter there, that's our term, and then the italics after that, that is the actual definition. So you're going to write down for matter, anything that has mass or volume. That's our scientific definition. And you can already see at the top there, I rephrased it. For me, I try to say it's the stuff that exists in the universe. That's basically what matter is. Matter will always have mass and volume, which are just two physical properties of matter. Most of matter we will talk about in class will be made out of different atoms. Yeah, so we're just combining different stuff, different types of matter to see how it interacts. And that's basically what makes up our universe. Physical properties, these are properties of matter that can be easily seen. The italics on the page is the definition that goes with physical properties. So these are things that you can easily see when you hold an object. It describes the physical characteristics of the substance. It's things like length, volume, mass, color, smell, hardness, density, and more. Basically, anytime you pick up an object and you're like, wow, I can describe this super easily, blah, blah, blah. Those are physical properties. They're things that you can physically see or manipulate about that substance. Mass is a physical property. It's the amount of matter in a substance. So it doesn't necessarily say what kind of substance it is, it's just how many atoms do we have? Does it have atoms? If it has atoms, then yes, it has mass. The base unit of measurement is kilograms. You can see that's noted by a kg in lowercase. And we will use a balance or scale to measure this if we ever come back in class, or you'll use that in the future when you go to science class. But mass is just the amount of matter in a substance. How many atoms does it have? Something to keep in mind is mass is not weight. Weight is the force of gravity acting on an object. So if you look at that picture, well, your weight is going to be different if you were on the moon compared to if you were on Earth. The moon has less mass, therefore it has less gravity. So when you go to the moon, it's going to be like you have less weight because it's not pulling on you quite as hard as the Earth is pulling on you. However, the mass stays the same because the mass is related to how many particles there are. And that isn't changing. You're made of the same number of particles on Earth as you are on moon. Therefore, the mass is constant. And that's why we tend to use that in science because it's a constant. It's something that you can use to describe a substance no matter where you are in the universe. So while we're talking about mass, let's talk about the law of conservation of mass. What does conservation mean? Go ahead and take a second, think about it. Where have you heard this term before? Maybe you've heard about conservation of plants and animals. You see that cute little panda there chewing on bamboo. Look at those cute little birds, those parrots. Yeah, conservation means to save. It means to preserve. So the law of conservation of mass says, in a closed system, mass stays the same. Mass is preserved, it's conserved, it doesn't change, is essentially what we're getting at here. Basically, the mass won't change unless something is added or taken away. That's all the law of conservation of mass is the mass, that number of particles is going to stay exactly the same unless you add some particles or take away some particles. Let's look at an example. So one example is if you take a log and you set it on fire. Yeah, so say you've got 30 kilograms of logs and 1 kilogram of fire. So fire is kind of like plasma, but it's got some particles in it. Technically, if you can see it, there's got to be some fuel that's burning. There's a lot of things to unpack there, but not the main focus. Basically, we start with 30 kilograms of log, 1 kilogram of fire. The law of conservation of mass tells us that no matter what happens, I have to have that same number of particles, that same mass, after this reaction. So when a log is set on fire, what happens to it? Do the atoms disappear? Go ahead and think about it. Picture a log. Picture it on fire. What does it look like after it's been burned? Well, it tends to turn to ashes and smoke. And so usually people take a look at the ashes and they're like, this is not the same amount of mass that we had when we started. And technically you're right. Basically what's happening is those atoms are changing slightly and they're moving around. However, the number of particles is still present. They're just not in that exact location or orientation. So after you're done burning a log, sometimes, you get 28 kilograms of ashes. You usually got to shovel out that chimney or fire pit. But you usually do have less mass than you started with, but not if you include the smoke. Even though smoke doesn't seem very heavy, a lot of smoke is given off during the burning process. Therefore, that smoke could be added up, and if we were able to contain all those particles, you can see 28 plus 3 does equal the 31 kilograms that we started with. And that is the law of conservation of mass. So we're going to notice how the mass of the reactants, that's our log and fire, those are the things that react to each other, equals the mass of our products. And our products, just like in math, it's like the end result. It's what we got after we added those things together. So law of conservation of mass all means the mass we start with, our reactants, is going to be equal to the mass of our products. Volume, another physical property. It's the amount of space something takes up. That's the definition. It's the amount of space something takes up. So the base unit of measurement is cubic centimeters or milliliters, which cubic centimeters is typically used for solids and milliliters is typically used for liquids. It can change depending on the state of matter. So this is the fun part about volume. Mass is always going to stay the same, no matter what state of matter, because all it is the number of particles. But volume, now we're talking about how much space is in between those particles. For solids, maybe you saw this in your investigation, those particles are going to be packed really tight together. There's not a lot of space in between them. But if you add some energy, you heat up those particles, they're going to start moving faster and faster, and the space between them will increase. And then as you keep heating them up for gases, it increases and increases, and the volume's going to get bigger and bigger. Now, when you go from a solid to a liquid, your volume is going to stay the same. We say that's a fixed volume. And that's because even though the molecules are moving around a little bit more, they're still stuck together. They don't have enough energy to break free from each other like they do when they're a gas. Which is why for gases, we say there's no fixed volume. Those particles are ping-ponging all over the place, just bouncing around, filling up whatever space they can. So volume is just the amount of space something takes up. Let's talk about chemical properties. A chemical property is a characteristic that can only be determined by changing the chemical identity of the substance. That's a mouthful. Basically what that means is a chemical property can only be identified when something is changing. We have to see it in action. We have to see some type of chemical reaction to see a chemical property. An example of that would be flammability. If I hold up a piece of paper, I can't just look at it and be like, wow, that's flammable. The only way to truly know is to set that puppy on fire. Now, I'm not going to do that. We have done other experiments where we see that things made out of paper are flammable. So part of science is we say, okay, we've done that over here, therefore I would assume this paper is flammable. So I don't necessarily have to test it out. But the first person who had paper to figure out if it was flammable, they had to find out by setting it on fire. Same thing is true for reactivity and tarnishing and rusting. Those things can only be seen while they're going through that process of reacting with something, whether it's oxygen, fire, another chemical. That's how you notice chemical properties. They can only be seen when a substance is reacting or changing to form a new substance. In the bottom right-hand picture, you can see all the different types of chemical properties that are out there. If this is confusing, go ahead and watch a helpful video. I've got a link to it in the corner. You'll have to go to the slides to see it though. So why do things have the properties that they do? Think about it. Pause for a second. Why do things have the properties that they do? Take about 20 seconds, pause the video, think about this question and see if you can answer it. Hopefully you took a second to answer it. I wanted you to think about it. I want to hear some answers from class, but ultimately, what we're getting at here is things have the properties that they do based on the atoms or the chemicals that make it up. It's based on what they're made of. Yeah. So let's practice identifying some of these properties, right? Our physical and chemical properties are determined based on what chemicals make up this thing. Yeah. So think for about 20 seconds and see if you can come up with any physical or chemical properties of this pencil on the screen. Pause the video now in order to make those predictions. All right, so for physical properties, those are things that you can easily see. So if you said it's made of wood, yeah, that totally counts. I can see, yeah, it's made of wood. If you said it's about 4 centimeters long, I mean, if you had this in your hand, that'd be a lot easier to see. But if you have a measurement, the length is a physical property. If you describe the color, it's yellow. I don't know why it says good, but it says yellow, orange, beige, gray. Good should not be there. But if you describe the color, yes, that's easily seen. That's a physical property. If you say it has a mass of about 12 grams, again, yes, physical property. The mass of it is just the number of particles. It doesn't have to do with the actual chemical composition. If you say it floats in water, density is a physical property. If you say it's a solid, state of matter is definitely a physical property. Now let's talk about chemical properties. Yeah, this puppy's flammable. I could set that pencil on fire. That's a chemical property. It's not acidic, meaning that it's not going to react with any kind of base or any other acid. And that metal part on the pencil will indeed rust. That rusting factor is a chemical property. So these are ways to identify physical and chemical properties of a substance. Let's try it again. Take a look at this Statue of Liberty. Pause the video, see if you can come up with physical properties and chemical properties. I already have one on the board to get you started. Hopefully you took a second to see if you could identify these physical properties and chemical properties. So first of all, the Statue of Liberty is made of copper, iron, and granite at the base. So those are physical properties. It's just 3.5 feet tall. This should actually be 305 feet tall. I don't know how the decimal point got there. It should be a 0. So about 305 feet tall, that is a physical property. It's green. It sinks in water. Yeah, it's made of metal. And it has mass of about 113,400 kilograms. Yeah, it's pretty heavy. Chemical properties, it's not flammable. You could not set this on fire. It's mostly made of metal. It's not acidic. However, it will rust or tarnish with oxygen. Originally, the Statue of Liberty was made out of copper. It was a vibrant coppery color, and it tarnished over time into the color that we see today. Now it's your turn to try. So we're going to do discussion number 2. This is in today's folder. You're going to answer, what are physical and chemical properties of your favorite object? You're going to pick one of your favorite objects. It must be physical. So you can't do video games, can't do music, can't do movies. It has to be something that you could physically touch or hold. You're going to describe its properties and explain why it's one of your favorite things. And of course, don't forget to post and respond. So go ahead and click on the discussion number 2. It's in today's folder. Be sure to read the instructions carefully. This is worth 15% of your grade. It's in that discussion category. And look at my example to make sure you do it right. Thank you very much, everybody, for watching this video. I hope it was helpful, and have a wonderful day.